Welcome to the start of our pagination course. In this initial unit, we're going to explore the essential theory behind pagination and its role in managing data, especially in the context of API calls. We'll delve into what pagination is, break down its various components, and understand how it's applied within an API environment. This foundation will equip you with the knowledge needed to effectively handle paginated data, an essential skill when working with large data sets or online platforms. Keep in mind that this is a theory-focused unit. Practical building will come later. Let's get started on this journey. When you hear the term pagination, it might sound complex, but it's quite simple. You've probably seen it in action whenever you search something on Google. Those extra O's you see at the bottom of the Google page representing different pages of results, that's pagination. It's a way to break down content into smaller, manageable pages, which makes it easier to navigate and digest. Let's compare it to a popular TV show like Friends. Imagine if the entire series was just one long continuous video. Finding specific episodes, like the one where Phoebe sings Smelly Cat, would be a nightmare. Instead, the show is divided into seasons and episodes. This organization helps you find and enjoy specific parts easily. In the same way, pagination acts like these episodes and seasons, organizing content on platforms like search engines. Each page of results is akin to a season or episode, allowing you to sift through information efficiently and without being overwhelmed. Why do we use pagination? Well, it serves several important purposes that make handling large amounts of content much more efficient and user-friendly. First, by splitting content into smaller, separate pages, we improve performance. Only loading a part of the data at a time reduces the load on your device and speeds up retrieval. Additionally, this approach greatly enhances the user experience. Instead of overwhelming users with endless scrolling, pagination lets them navigate content in manageable chunks, making it easier to find exactly what they are looking for. It also significantly reduces server strain by limiting the amount of data processed with each request, helping avoid timeouts. Finally, pagination supports scalability, allowing systems to handle increasing amounts of data gracefully. In essence, pagination optimizes the way we interact with large data sets, making digital experiences smoother and more enjoyable. Let's dive into why pagination is so valuable. Imagine trying to find a specific piece of information on a website that loads all its content on a single, endless page. Not only would it be overwhelming, but it would also slow down your browsing experience significantly. Pagination addresses this by breaking down extensive content into smaller, more manageable chunks. This not only improves usability by making information easier to locate, but also enhances overall user experience. By allowing users to navigate content in a sequential manner, it reduces the cognitive load and streamlines the process of finding exactly what they're looking for. Ultimately, pagination ensures that large amounts of data are organized effectively, making interaction with the content more intuitive and efficient. When dealing with large data sets, efficiency is key. Imagine trying to load an entire library's worth of books at once. Your system would likely struggle, and this is exactly where pagination becomes valuable. By sending smaller chunks of data rather than the entire data set, we significantly reduce server load. This not only optimizes server performance, but also speeds up response times for users. When the server is less burdened with massive data requests, it can handle many more operations smoothly and quickly. This approach frees up resources, allowing multiple users to access information seamlessly, ultimately enhancing the overall user experience. When dealing with large volumes of data, timeouts can become a significant issue. Imagine trying to load an enormous data set all at once. This can overwhelm the server, causing delays. To combat this, pagination retrieves data in smaller, manageable chunks. This approach helps prevent timeouts by ensuring the server responds promptly without overloading. When a server takes too long, it risks cutting off connections, leading to frustrating delays for users. By implementing pagination, we enhance the system's efficiency and provide a smoother, more reliable user experience. Pagination is an essential tool for managing vast amounts of information online. Picture a scenario where an entire website's content loads at once. This would lead to slower performance, increased server strain, and potentially frustrate users waiting for all data to load. Pagination helps by breaking content into smaller, more manageable sections, improving performance and creating a smoother user experience. By presenting information in increments, users can navigate more easily, avoiding the overwhelm of excessive data all at once. This approach not only enhances scalability but also optimizes server usage, preventing timeouts that occur when a server takes too long to respond. Ultimately, pagination ensures that both users and servers operate more efficiently, delivering content effectively and responsively. Let's explore what happens when Florence, a huge fan of the TV show Friends, goes online to search for information. Imagine she types friends into Google and suddenly faces approximately 12 billion results. Displaying all these results at once would not only cause long loading times, but also make it nearly impossible for her to find what she's truly interested in. This is where pagination becomes crucial. By breaking down the results into smaller, manageable pages, users like Florence can experience shorter loading times and a more seamless browsing journey. Pagination enhances user experience by organizing data in an easy to navigate format, enabling users to find relevant information without feeling overwhelmed. It's a simple yet powerful tool that keeps vast amounts of information accessible and user friendly. Imagine Oscar, who runs an online store filled with all the Friends merchandise you could want. If he put every item on the homepage at once, it would take ages to load, making it hard for Florence to quickly find Joey's cup that she's looking for. Instead, Oscar wisely uses pagination. By displaying a few items per page, he makes shopping a smooth experience, speeding up load times and helping Florence easily navigate to what she wants without delay. Pagination is crucial for managing large inventories efficiently, preventing website overload, and ensuring customers have a seamless and enjoyable browsing experience. When you're working with APIs, understanding pagination can be crucial for efficiently retrieving data. Imagine making a call to an API. It doesn't return all available data at once, but only a segment of it. Think of it like watching a TV series. You only see one episode at a time. This process is similar when accessing data through APIs. You need to make repeated calls to fetch the entire set, just as you would watch subsequent episodes to complete a season. Now consider Florence, who wants to watch all the seasons of her favorite show. With pagination, she can sequentially access each season by sending repeated requests for new data pages. Mastering pagination involves knowing which parameters to adjust in your API calls to navigate through all available data efficiently. This skill ensures you capture every piece of information you need without overwhelming your system or missing out on parts of the data set. When working with APIs that use pagination, there are two crucial aspects to consider: making the right API calls and determining how many times you need to repeat these calls. First, you'll need to ensure you can extract all the data by repeating API calls page by page. This involves identifying the necessary parameters, which you can figure out by reviewing the API documentation and conducting test calls. It's not just about fetching data, but doing so efficiently. Calculating the number of repetitions you need ensures you don't miss any data pages, while avoiding unnecessary API calls that could waste resources. Throughout this course, we'll guide you on how to determine this number effectively, ensuring you retrieve complete data sets with precision. To efficiently manage paginated data, you'll need to repeat API calls to gather all the information available. This could seem daunting, but thankfully the repeater module simplifies the process. Its primary role is to automatically repeat a task, such as an API call, a specified number of times. You determine the exact number of repetitions based on the data you need to retrieve. This approach helps streamline your workflow and ensures you don't miss any data. As you build scenarios later on, you'll delve deeper into how this module can be effectively utilized. When working with paginated data, the main challenge is that each API handles pagination uniquely. There's no universal standard, which can feel intimidating at first, but don't worry, there are ways to navigate this complexity. Small, manageable steps will help you identify how to effectively retrieve paginated data from any API. Exploring different strategies can make the task much simpler. So, let's dive into these steps and uncover the methods that can streamline your data retrieval process. Dealing with paginated data can be daunting due to the varied ways each API implements it. Your first step is to dig into the API documentation to determine if pagination is used. A great starting point is checking for a dedicated pagination section, which can provide valuable insights into how pagination works for that specific API. If this section doesn't exist, take a closer look at the query parameters. These can offer crucial clues. Parameters such as page are strong indicators that pagination is in play. Understanding what each parameter does will help you tailor your API calls effectively, ensuring you retrieve the data you need without unnecessary frustration. Understanding how to retrieve paginated data is key when working with APIs, as each API might implement pagination differently. The first step involves identifying the parameters needed in your API calls to access different pages of data. Common parameters include terms like page, next page, page size, page token, cursor, and offset. These serve as instructions within your API call to specify which segment of data you want to retrieve. It's essential to delve into the API documentation, as it often contains examples of API calls that demonstrate how these parameters are structured. This can provide you with a clearer picture of how to effectively set up your requests. Moreover, familiarizing yourself with general pagination types can greatly assist in deciding how to organize your API calls. By understanding these basics, you're setting the groundwork for efficient data retrieval, making it easier to handle various implementations of pagination across different APIs. Keep exploring these concepts to improve your ability to navigate diverse API systems effectively. Understanding how to retrieve paginated data from an API is crucial for efficient data handling. Every API has its own unique way of handling pagination, so it's essential to know both what parameters you need to include in your request and which ones you can expect in the response. Start by diving into the API documentation. You'll usually find an example response, often in a section dedicated to pagination. This example can help you identify the parameters that are returned and how you can use them to navigate through multiple pages of data. Look for indicators like next page tokens or cursors, which can tell you if more data is available and how to request it. This process might involve looping through requests until you've retrieved all the necessary data. By thoroughly examining the API response, you can efficiently determine how to calculate and manage the number of subsequent requests you need to make. Remember, thorough documentation review is key to successful data retrieval from paginated sources. Let's explore how to test your first API call for retrieving paginated data. Now that you're familiar with how pagination is implemented, it's time to see it in action. Begin by making an initial API call using the standard parameters. This call will retrieve data from the first page and give you a practical glimpse of how the API functions. This initial test is crucial. It allows you to analyze the response structure and determine what adjustments might be necessary for subsequent calls. In some situations, this first call helps calculate how often you'll need to repeat the process to gather all desired data. Remember, while this call provides valuable insights, it might not be part of your final solution. Think of it as your sandbox, a place to experiment and understand the terrain before you start building. In this stage of retrieving paginated data, we're diving into the planning phase of your API call. Understanding that each API may handle pagination differently is key. There's no one-size-fits-all rule, so being informed on how your specific API functions is essential. You've completed the groundwork and now have a grasp on the parameters needed for your call, as well as the type of response to expect. This knowledge equips you to craft a precise API request using the HTTP modules available. Your goal is to construct an efficient request that smoothly navigates the pages of data you intend to retrieve. Remember, thoughtful planning now will ensure smoother execution later. This step sets the stage for effective data handling, ensuring you can efficiently manage and retrieve all necessary data from the API. When working with paginated data, one of the key challenges is calculating the number of repetitions for your API calls. This can vary based on how pagination is implemented by the API you're dealing with. For classic page-based pagination, this task is quite straightforward. Typically, you'll find a parameter like total pages in the response. Using this information, you can easily determine how many times you'll need to request additional pages. This approach allows for a clear plan in handling your data retrieval efficiently. However, when it comes to cursor-based pagination, the process is a bit more complex. Unlike page-based pagination, cursor-based methods don't offer a direct parameter to tell you how many pages exist. Instead, you'll need to implement a mechanism that tracks when there are no more pages to fetch, often by checking for an empty response or a specific endpoint signal. Understanding these approaches will not only enhance your efficiency in fetching data, but also give you the flexibility to adapt to various API implementations. As you continue, you'll gain deeper insights into different pagination techniques, preparing you to master the art of handling paginated data effectively. When working with data pagination, it's important to familiarize yourself with some key terms that guide the process. Let's start with page. This refers to a single subset of data returned by an API, similar to flipping through pages in a book. Each page contains a fixed number of items. Next, we have the total count, which tells us the overall number of items available in the data set. This helps gauge the scale of the data you're working with. Limit is all about controlling quantity. It specifies the maximum number of items that can be included in a single page. Think of it as setting a cap on how much data you handle at once. Moving on to total pages, this indicates the number of all possible pages, calculated based on the total count and the limit. Then there's offset. This term is crucial for navigating through data. It represents the starting point within the complete list and is often used to skip a specific number of items before beginning to collect data. Cursor is used in cursor-based pagination, a method that codes the last item from a previous page to determine the start of the next. It's like a bookmark that helps you resume where you left off. Finally, key can either refer to a unique identifier used in pagination or a value that unlocks another layer of understanding in your data retrieval process. Understanding these terms enables you to effectively navigate through paginated data, ensuring you retrieve all necessary information efficiently. Imagine watching a TV series like Friends. Each season you watch can be compared to a page of data obtained from an API. In technical terms, a page is a subset of data returned by an API, usually containing a fixed number of items, much like a season contains a set number of episodes. When you make your initial call to start watching, you're accessing the first page. This would be akin to beginning with the first season of Friends. This opener includes episodes like the pilot and the one where Rachel finds out. As you continue watching, you might want to go back to a previous season or move on to the next one. Similarly, in API pagination, there are often links to move to the next or previous page of data. These links function like buttons to switch between seasons, letting you navigate through the data seamlessly, episode by episode or item by item. Let's explore the idea of total count. When you're diving into a series like Friends, the total count represents the complete number of episodes you can watch. In the context of data sets, this is akin to knowing the entire scope of the data available to you, often provided by an API. It's like being given a sense of the entire collection you'll be accessing, so you can plan your viewing or data retrieval accordingly. Just as Florence can see how many episodes she has to look forward to, having this total count helps you understand the full landscape of what you're dealing with. This awareness allows you to gauge progress and make informed decisions about managing your time and resources. In the world of streaming and data, limit is a handy term. Imagine you're settling in to watch your favorite show and you decide you only want to watch 3 episodes tonight. That's your personal viewing limit for the session. Similarly, when dealing with paginated data, the limit is the maximum number of items displayed on a single page. This can be customized by you, like choosing to view only 5 results at a time, or it might be predetermined by the provider, perhaps showing a fixed 10 results per page. Understanding limits helps manage information and consumption efficiently, ensuring you don't get overwhelmed, just like knowing when to take a break after a binge watch session. Total pages refer to the number of pages needed to show every item in a data set. You can think of it like a book, where each page holds a portion of the whole story. If we continue with our Friends analogy, imagine each season of the show as a page. The total pages are like the total number of seasons Florence must watch to see the entire series. This concept helps understand how data is split into manageable sections, making it easier for users to navigate large data sets effectively. Let's take a deeper look into the concept of offset within a paginated system. Imagine you're browsing a long list of items, but you want to start from a specific point. Offset is the number that tells the system how many items to skip over before starting to show the list. For instance, consider that Florence wants to watch the 3rd episode of her favorite show, Friends. Since she wants to skip the first 2 episodes, the offset would be set to 2. This means the system knows to start from the 3rd episode. Offsets are commonly used in data retrieval systems and can be labeled with terms like offset, $skip, or start index. They help efficiently navigate through large data sets by specifying where to begin. Understanding how offsets work can enhance your experience when dealing with any large collection of data, ensuring you can jump right to the content you need with ease. Imagine you're watching a series like Friends on your favorite streaming service. You pause at a certain point, and when you return, the platform picks up right where you left off. This is the power of a cursor. In a technical sense, a cursor acts like a pointer or a bookmark. It keeps track of your precise position within the data set, ensuring efficient retrieval of information when needed. So when Florence stops her episode and comes back later, the system seamlessly uses this cursor to resume. This functionality not only improves user experience by saving time and effort, but also optimizes data management in a paginated system. In the world of data management and streaming, a key plays a pivotal role. Think of a key as a unique identifier that contains details about the current data page being viewed. This identifier is essential for ensuring that when you fetch the next set of data, you pick up right where you left off. Imagine Florence binge watching Friends. Each episode has its own unique code, like S01E01 for Season 1, Episode 1. This code acts as a key. If Florence wants to jump directly to an episode without scrolling through an entire list, she can simply use this key to instantly access the desired episode. In the same way, when an API retrieves data, it uses keys to know exactly where to go next, making data retrieval efficient and seamless. This system ensures that moving between data pages or episodes happens smoothly, enhancing user experience by eliminating unnecessary wait times or confusion. When we talk about pagination types, one common method is page-based pagination. Think of this like browsing through a TV series by season. Each season acts as a page, providing a fixed set of episodes. Just like how Florence can select and view an entire season of Friends, page-based pagination lets users access specific sets of data at a time. This approach is straightforward. Each page contains a set amount of content. It's like flipping through an album where each page reveals a new chapter. By moving through these pages sequentially, you can explore all the content step by step. This method keeps things organized and easy to navigate, ensuring users can access the data they need in a structured way. Offset-based pagination is a method that helps users jump to a specific part of a dataset without having to go through every item. Imagine you're watching a TV series and you want to start at a particular episode. By setting an offset of 2, you can skip directly to the third episode, bypassing the first 2. This approach is particularly useful in large data sets where you might need to bypass a set number of entries to find the data you want. It works by using an offset parameter to determine where the data retrieval begins, allowing for efficient navigation through vast amounts of information. While it's straightforward and flexible, remember that it can become less efficient with large data sets since each request still counts from the beginning, impacting performance as the offset increases. In cursor-based pagination, think of it as having a bookmark in a book. When Florence watches Friends on her favorite streaming platform, the app remembers exactly where she paused using a pointer or cursor. This means that next time she hits play, the platform takes her right back to the spot she left off. It's as if the streaming service uses a key to unlock her specific episode in time, ensuring a seamless viewing experience. Unlike offset-based pagination, which could skip too far ahead if new episodes are added, cursor-based keeps Florence on track, focusing on a precise continuation from her last session. This method is especially valuable for large data sets or continuous streams of data, where efficiency and precision are crucial. In the world of APIs, pagination is a crucial concept that helps manage large data sets effectively. One type we're exploring today is keyset-based pagination. This method uses a unique identifier such as an ID or timestamp to guide users through data. Think of it as being a bit like using bookmarks in a book. For instance, if you're watching a series like Friends, each episode can be marked by a unique alphanumeric code. By entering the code for the last episode watched, the streaming platform knows exactly where to pick up when you're ready to continue. From the end user's perspective, keyset-based pagination is quite similar to cursor-based pagination. Both systems employ identifiers to track progress through the data set. This makes encountering your data seamless and intuitive, whether for binging your favorite show or navigating through extensive data sets. In software development, APIs often use pagination to manage large data sets efficiently. Each API might implement pagination differently, but some common methods are frequently used. These include page-based, offset-based, cursor-based, and keyset-based pagination. Each of these has distinct advantages and uses specific parameters like page numbers or unique identifiers to fetch the data in chunks. Beyond these standard types, there are innovative approaches combining various elements to address particular needs. Such tailored strategies are crafted to optimize performance and handle unique challenges, making them ideal for specific applications. However, while these customized techniques offer flexibility, they can also complicate the process of retrieving paginated data. Developers must balance designing a system that meets their application's needs with the complexity it may introduce when interacting with the API. Ultimately, choosing the right pagination method depends on the specific requirements of your application and the nature of the data you're handling. This adaptability allows developers to create efficient and scalable solutions, even if it involves managing some complexity. When dealing with APIs, a crucial step is understanding how pagination works within your chosen API. Let's explore this concept using an example involving the NASA API, which allows you to retrieve a range of images. To start, it's essential to dive into the API documentation. First, you'll want to investigate whether pagination is required. This often involves checking if there are any pagination-related parameters or sections mentioned in the documentation. These parameters might specify how data is divided across multiple pages, allowing you to access comprehensive datasets systematically. The next step involves identifying how to make the API call correctly. This means ensuring your request includes any necessary pagination parameters, such as page numbers or limit values, to successfully retrieve the required data. Finally, examining the API response is vital. You'll need to scrutinize how the data is returned, looking for pagination indicators such as next page links or offsets, which signal that more data is available beyond the current response. By thoughtfully reviewing each of these steps, you'll be better prepared to implement a pagination strategy that effectively retrieves all your desired data from an API, such as NASA's. To determine if pagination is part of an API, begin by checking the documentation for a dedicated pagination section. If absent, it's important to examine the specific API method you intend to use. Take, for example, a search operation. Here you'll look into the parameters named page and page_size. These parameters confirm the presence of pagination. The page parameter typically specifies which page of results you want to access starting from page 1. Meanwhile, page_size controls the number of items displayed per page. Understanding these parameters is crucial as they enable you to effectively control and navigate through extensive data sets, ensuring that you can retrieve the information you need efficiently. Now that you've identified pagination in the API, it's important to understand how to utilize it effectively in your API calls. At this phase, you'll focus on the parameters that can be included to specify exactly which data you want to retrieve. This API uses a page-based pagination system, meaning you'll include two key parameters, page and page_size. The page parameter allows you to define which page of results you're interested in. For instance, setting it to 1 will fetch the first page. Meanwhile, page_size lets you decide how many items you want to see on each page. Adjust these values to manage the volume and organization of data returned in your responses effectively. Incorporating both parameters into your API call is crucial. It not only helps streamline your data retrieval process, but also optimizes performance by ensuring you're fetching only the necessary amount of data at a time. This approach can significantly enhance the efficiency of your applications, particularly when dealing with large data sets. When you receive an API response, it provides essential information that guides your next steps. One key element is the right single quote metadata.total_hits right single quote comma, which indicates the total number of items you can access. This helps you understand the volume of available data. Another important component is the links section. This array includes multiple URLs, each representing a different page of data. If there are additional pages, you'll find links labeled as prev or next, allowing you to navigate through the data sequentially. However, keep in mind that the first page won't include a prev link and the last page won't feature a next link. This structure helps you efficiently manage data retrieval in a paginated format, ensuring you always know what data is available and how to access it. Now that you've identified how the pagination is set up, let's put it into practice by testing your first API call. When making a call to the API, you'll start by using the default settings to access the first page, retrieving 10 items. As you analyze the response, you'll notice under the metadata section the total number of items available, shown as total_hits. This gives you a complete overview of what's accessible through the API. Pay attention to the links section, specifically under the href attribute of the next link. This provides the URL needed to fetch the subsequent page, making the navigation through results straightforward. The choice of 10 items per page was arbitrary, aiming to keep the data manageable while you explore. Depending on your query or any API constraints, you might want to adjust this. Remember, because we're fetching the first page, there's no previous link available. As you proceed, consider how this first call fits into your overall scenario planning. As you plan your API call, it's essential to understand how pagination works for your specific API. Pagination is a method used to divide large data sets into smaller, more manageable chunks, which are presented on different pages. This allows you to retrieve and process data more efficiently. In our case, there are two main strategies for handling pagination. The first option is to use the next URL provided by the API. This URL typically includes a parameter for the page number, making it easy to move forward through the dataset. The second approach is to manually add and update the page parameter in your query string. With each API call, you increment the page number to retrieve the next set of data. This method is often simpler to implement, which is why we'll focus on this option. In upcoming lessons, we'll explore use cases with both strategies, helping you decide which is best for your specific scenario. Remember, mastering pagination is key to efficiently accessing and utilizing large data sets through APIs. As we delve into planning your API calls, one crucial element is determining how often these calls should be made. Essentially, we're figuring out the number of repetitions required for your API requests. This involves a few thoughtful steps. First, assess whether you can effectively calculate how many times you need to repeat the call. This calculation is vital for ensuring your data retrieval process is accurate and efficient. Next, decide on the implementation strategy. Consider whether the initial API setup will play a role in this calculation or if it might become redundant. Streamlining your process not only makes it more efficient but also prevents unnecessary API calls, saving resources. Thinking through these aspects prepares you for a smooth API integration and aligns your approach with the pagination strategy already observed. By carefully planning, you'll be able to execute your API calls with precision and purpose. Now that we're ready to determine how many times we'll need to repeat our API calls, let's break it down. Imagine you have 41 total items to retrieve. In each API call, you can fetch 10 items per page. This is where we use pagination to our advantage. To figure out how many pages or API calls are needed, we divide the total number of items by the items per page. So we divide 41 by 10, which gives us 4.1. But since you can't have a fraction of an API call, you'll round this number up to 5 using the ceil function. This calculation ensures you retrieve all your items in an efficient way. Keep in mind, the total number of items will depend on the query, so this needs to be calculated dynamically each time. Let's proceed to see how this fits into the bigger picture of your data retrieval strategy. When designing your API call for pagination, it's important to calculate the number of pages you'll need to retrieve all data. Here, we have 41 items in total. To organize these efficiently, we've chosen to display 10 items on each page. To figure out how many pages or repetitions you need, divide the total number of items by the items per page. In this case, you'll perform the calculation 41 divided by 10. Since 41 divided by 10 gives us 4.1 comma, and you can't have a fraction of a page, you round up to the nearest whole number. This is where the ceil function comes in handy, converting any decimal result to the next highest integer. By using this method, you'll find you need 5 pages to cover all items. Utilizing functions like ceil ensures comprehensive data retrieval without missing any pieces. This step is crucial as it forms the foundational structure for pulling data efficiently through the API. To effectively manage the number of repetitions in our API calls, we'll begin by using the data received from the first API call. This initial call provides crucial information about the total number of hits, which we will use to determine how many pages of data we need to retrieve. It's important to incorporate this first API call early in your scenario to accurately map out the number of required repetitions. Remember, since each search can yield a different number of results, You'll use the total hits from this response to calculate the necessary iterations for retrieving all data. Before implementing the repeater module, you will add an HTTP request module. This module's sole purpose is to capture the total underscore hits parameter, which guides us in structuring the subsequent API calls. While the data from this initial call won't be used directly to retrieve information, it serves as a foundation for calculating how many times the repeater module should operate. After determining this, you'll proceed to use the repeater to systematically fetch each page, ensuring you cover the entire dataset efficiently. This process helps streamline data retrieval and avoids unnecessary API calls, optimizing your interaction with the API. Let's take a moment to recap the essential steps for planning a successful API call. First, dive into the documentation to understand if pagination is required. This helps you manage how data is retrieved in batches. Next, examine the specifics of the API call itself. You want to be clear on how requests should be structured. Moving forward, studying the API's response will inform you of the metrics you'll be working with, ensuring you capture all necessary data fields. Testing the first API call is crucial. This step is where you verify that the call works as expected and retrieves accurate data. With this insight, you're ready to strategically plan your API call. Consider how you'll handle pagination and manage data flow efficiently. Finally, determine how to calculate the number of repetitions needed to fully process the retrieved data. In practical terms, think about strategies for managing calls efficiently, especially when all information isn't directly available, such as total hits. As we progress, we'll explore how to apply these principles to real-world scenarios using tools like the NASA API. This gives you hands-on experience with maintaining efficiency and precision in your API interactions. When working with APIs, handling pagination effectively is crucial, especially when you don't have explicit information about the total number of items. Typically, metadata like total underscore hits provides an overview of the total items available, helping to determine how many pages you need to iterate through. However, there might be cases where this information is missing. In this scenario, you need to dynamically manage pagination by focusing on the links section of your API response. This section often contains URLs leading to subsequent pages of data. For instance, links. One.href right single quote provides a URL to fetch the next page. Using this URL, you can continue retrieving data until you stop receiving new links, signaling that you've reached the end of the data set. This method requires you to programmatically check for the presence of a next page link in each response, ensuring you don't make unnecessary API calls if there are no more pages to fetch. This approach helps maintain efficiency and prevents issues with rate limits or excess data usage. In this step, we're focusing on effectively planning your API call strategy, particularly when dealing with pagination. Often APIs may not provide a total number of items or pages up front. This means you'll need to rely on other clues in the response. Our approach here leverages the next URL provided in the API response. This URL indicates the next page of data and is a key part of our pagination strategy. You'll use it to automatically navigate through pages. It's important to note that this next link will only be available if there's another page to fetch. Once you reach the last page, this link won't be present, signaling that you've retrieved all available data. Understanding this mechanism ensures you're not missing any information and can efficiently manage data retrieval in your application. When working with APIs, a common challenge is handling pagination, especially when the total number of items isn't provided. This might leave us wondering how many pages we need to fetch. Even if we know the number of items per page without knowing the total count, we can't determine the number of repetitions automatically. This scenario requires a dynamic approach, where each API call checks if there's a subsequent page to load. By doing so, the process will naturally stop once all available data is retrieved. Let's dive into techniques to tackle this efficiently, ensuring you can handle these scenarios with confidence. When dealing with APIs where the total number of items isn't provided, you can effectively manage pagination using available signals. One crucial indicator is the absence of a next URL when the last page is reached. This serves as your cue to stop further requests, avoiding unnecessary repetitions. Implementing a filter can streamline this process by automatically skipping any bundles that don't include a next URL. This ensures your API calls are efficient and precise. You'll gain hands-on experience with this approach in Unit 3, where we'll walk through the implementation step by step. When working with APIs, dealing with pagination is often a necessary step, especially when retrieving large sets of data. Sometimes the API does not provide the total number of items or pages up front, which means we need a strategy to handle this uncertainty. The key is to avoid endless API calls. By implementing a method that stops requests when no more data is available, you ensure the process is efficient and effective. Consider whether an initial API call is essential. Often it isn't needed if it won't provide information on the number of pages or items. Instead, focus on setting conditions that terminate the process when the API indicates there are no further pages. This approach not only saves resources, but also streamlines your workflow, allowing you to focus on building a robust scenario that meets your data needs. Congratulations on completing this unit. You've explored the concept of pagination, an essential tool for managing large sets of data efficiently. Understanding why pagination is used helps you see its value in optimizing API calls and improving data transfer. As you fetch paginated data, it's crucial to consider factors such as the number of items per page and the total number of available pages. This ensures your application can handle data seamlessly without overburdening resources. Studying API documentation is a key skill. It allows you to plan how your calls will handle paginated data effectively, taking into account the specific requirements of each API. Defining the number of repetitions is equally important. By implementing a strategy to determine when to stop fetching more data, you prevent unnecessary API calls and enhance performance. This is just the beginning. In upcoming units, you'll deepen your understanding and apply what you've learned in practical scenarios. Exciting challenges await you, so get ready to dive even deeper into pagination